Hey guys, Mr. Peterson here, and today we're going to be talking about the natural base, which is e. And some of the goals that we're going to have are to use e to write exponential functions, to represent real-world situations, and to solve equations and problems involving e and natural logarithms. Well, first of all, you might be wondering, what is e? Well, e, which is a lowercase e, is an irrational number. Just like pi, it's a number that kind of occurs in the real world, in kind of unlikely places. For instance, you often see it with compound interest. You see it with half-life. So first of all, well, what is e? E is just is like we said, it's an irrational number, and it's approximately 2.71. Whereas, like pi, also an irrational number, approximately 3.14. E behaves the same way. It continues endlessly, where there's no pattern in the way that the digits might repeat themselves. So that's E. We have two definitions that go with this lesson. We have a natural logarithm and the natural logarithmic function. So I'd like to pause the video now and let you guys go ahead and write that down. Okay, now we're back. A natural logarithm is just a log with a base of e. It's abbreviated. Abbreviated is spelled wrong there. Abbreviated as ln, kind of like log natural or natural log. In other words, guys, it's like a log. Where's my pen? It's like a log where the base is e. It's like a log with a base of e, but we don't write it like that. We just call it ln, the natural log. And then a logarithmic function is we can see here, it's the red line in this graph. We can see that's the parent function of the natural logarithm, and then on the blue graph we have its inverse, which is e to the x power. We have the inverse, so they're inverses of each other. All right, so first of all, in example 1, we need to simplify these expressions. So we're going to use a lot of the properties that we've learned with logarithms here, because they still apply. Logarithms and natural logs, all the properties that we have learned for logarithms, they transfer over to natural logarithms. So for instance, if we have ln, the natural log of e to the negative second t power, what that's really saying is e to the what would give us negative 2. So that's the answer is negative 2t. Excuse me, I said e to the what would give us negative 2t, and the answer would be negative 2t. Here we have the exponential version of this, e to the ln power of e to the ln of t minus 1. And so our answer here would be, if we wanted to evaluate it, it would be t minus 1. And then e to the 5 natural log of x. Well, we need to think about our properties of exponents, or excuse me, our properties of logarithms. If we had a 5 out in front of a logarithm, it would jump up and become the exponent. So this is really x to the 5th power, x to the 5th power. And so we're going to stop right here and do a couple problems. Okay, take a stab at that one. Okay, now try this one. And try this one. Alright, good. Today in class, when you get here, we're going to be exploring some of the more problem-solving applications and applying some of these patterns that you've seen in these few examples. We'll see you then.